So on this activity, we're going to discuss the chapter 8, subnetting IP networks. Then, so the broadcast domain, the other device's address resolution protocol, which stands layer to broadcast to a known IPv4 address on a local network to discover the associated MAC address. Services a host typically requires its IPv4 address configuration using Dynamic Host Configuration Protocol or DHCP, which sends broadcasts on the local area network. Okay. Problems with a large broadcast domain. The broadcast domain is very large. Slow network operation because the amount of traffic it can cause, and slow device operation because the device must accept and process each broadcast packet. So the solution for this is uh, to using subnetting. The process called subnetting. The we will able to divide the IP addresses, and put it on the different interfaces of it, and um, create a local network on a different port of the router. Then the reasons for subnetting is Uh, for example, subnetting reduces overall network traffic because it uh, the subnetting what subnetting does is it divides the devices per um, per per router. Example, this LAN 5 is connected to the gigabytes 0/4, and this LAN 4 is 0/3, and this LAN 3 is 0/2 up to gigabits Ethernet 0/1. So on this, every floor, they will able to they will able the traffic of their network will not that massive because they are divided into five. Next is as we can see here, the different network is connected to the router, and the router is connected to the internet. So the the network for the administration, student accounting, and human resources will not produce that large traffic of networks because they are on the different ports of the router. And then also this subnetting by device type, like all on the first gigabit 0/0 is all hosts, then on the next local area network is all printers, then on the last is all servers. So on that, uh, you will able to organize your network and reduce traffic. Then next, octet boundaries. Octet boundaries, subnetting network on the octet boundary. So the network has a different the IP address has its different prefix length. Like this, it is depend on the subnet mask of a network. So the IP address with a prefix 8 or subnet mask of 255.0.0.0, it has 8 networks with 24 hosts, and the number of hosts is 16,777,214, and the prefix length and the IP address with a prefix length of 16 has a subnet mask of 255.255.0.0, has 8 bit network, and oh no, not 8 bit network, have a 16-bit network and also a 16-bit host. Then the number of hosts is 65,534, and the prefix length of 24 has a subnet mask of 255.255.255.0, which means that on binary, the subnet mask has a 24-bit 24-bit of network, then 8-bit of host, and the number of hosts possibly done on this subnet mask is 254. The next, subnetting and the octet boundary, like the first one. Okay, it's like the first one. We start with a 10.0. Next, next classes subnetting. Wait a minute. Okay, the prefix length is 25. The subnet mask is 255.255.128. So in subnet mask, it borrow one host to become a network. Now it's a composed of two subnets because 2 raised to 1 is 2, and the number of hosts is 126. Why does it? Because the number of hosts 1, 2, 3, 4, 5, 6, 7. It has 7 number of hosts, and 2 raised to 7 is 128 minus 2. So it has 126 hosts. Then the next is 62. Then the subnet mask is 255.255.255.192, and it borrowed two hosts as its network. So the number of subnets is 4 because 2 raised to 2 is 4. Then the magic number is 62. 64 minus 2 is the number of hosts, and the rest, that's that's a computation, and the rest of this subnet mask ends by 9. So next classless subnetting. Hmm. So classless subnetting, we have a 192.168.1.0 with a prefix length of 24 network. Subnet mask is 255.255. So mm, okay, if we are able to borrow one to the host portion, then the borrowed bit value is 0 for the net 0 address. Then the borrowed bit value is 1 for the net 1 address. Then the new subnet has the same subnet mask, and it's now that that's more. Let's proceed. Creating two subnets. Okay, for me, for me, I tried to, I studied it by myself, so I'm a little confused about subnetting, but I will practice it, so I will able to do subnetting in the future. So the address subnetting topology is uh 25 prefix length. Then the network address is the network address is 192.168.1.0 is the network address. And the first host address is 192.168.1.1. That's the first host address. And the last host address is 192.168.1. Dot the first host address must be uh it the all of the host address, it should be 0, except the last, it should be 1. Okay, then the last host address is all of it is 1, then the last is 0. Hmm, okay, then the broadcast address is it's all 1. Okay, okay, I get it. Now if our barrow is number one, so it's 128, then the first host address will be 1.129. The last host address will be 254 because it has 1 here, and the rest is will be 1 and 0, and the last binary value is 0. Then the broadcast address is okay. Reset. Then let's continue subnetting formulas. Subnetting formulas is 2 raised to n equals borrowed bits borrowed. Okay, 2 4. Okay, I think I've already done that earlier. The formula and bits remaining in the host field. So if 7 bits 32 minus 3 is equals 30. Mm, okay, then creating 4 subnets. Then buying 2 bits. So it will be 0, and the second value is 1, 0 1. So it will be 64. The next is 128, and the next is 192, and the rest will be 0, and the subnet mask is 192. Then okay, the host remaining is 62 because 2 raised to 6 is 64 minus 2. The network address will be 0.0.0.1. That's 0, the network address, and the first host address will be 0.0.0 0.0.0.0.0.0.1. So it was 192.168.1.1 slash 626. Then the last host address would be 0.0.1111110, so 192.168.1.62. Then the broadcast address is dot 63. Then okay, creating subnet mask. So it's like the other, but we'll borrow bits from here, not here. So let's continue. Creating 100 subnet masks. So from here, we'll start borrowing from here until here because it we can borrow a bit to the 31st to the 31st host to the 31st bit of our host address. Next, calculating the host. Hmm. Calculating the host is we're going to raise to up to how many zero here, and then minus 2. Okay, and the first host address is here 1, and okay, then wait, okay, now I get it. Okay, just skip this. Subnetting based on host requirements. 120. Okay, 24, 128, 28, okay, it becomes 0, 128, okay, it's gonna, so, okay, traditional subnetting ways address. Hmm, this is subnet portion, then, to raise to 3 equals 8 subnets, and host portion is, 2 raised to 5 minus 3 equals 30 IP address. So 30, hmm, okay, done. And then just add, okay, okay, to calculate how many is unused address. Uh, raised to 5, the host portion, and minus 2. So we have a 30. Then 30 minus 28, each one subnet has weighs 28 addresses. So 30 minus 2 is 28. Then 28 times 3 times 3 is 84 unused address use. Okay, then variable length subnetting. Uh, for me as myself, when I understand this VLSM, it is subnet. It is a subnet of subnets to make the size of host smaller, or to divide each to different IP, or to different host address. Mm, okay, let's look at the VLSM. Oops, it's just topology. VLSM chart. Dot 1 dot 30, and okay, the 27 VLSM subnetting 192 dot 168 dot 20 dot 0 dot 24 to satisfy the first host needed. It used the prefix length of 27, or it borrowed three more three more um three more bits, and to satisfy the next, it it borrows another three from the bit from the yung tirang bit sa 27. Video. Network address planning, student LAN, faculty LAN, admin LAN. So planning requires decision each subnet in terms of size, the number of hosts per subnet, and how host address will be assigned. Planning the address the network to prevent duplication of address, provide control access, monitor security and performance. Planning address distributed, prevent duplication to manage the to s- to manage and secure that the different IP address is unique. The different IP address are unique, and to provide control access, so that um, there are no a lot of waste of IP addresses, and monitor security and performance to, I think, to, like, on smart on private IP addresses like that, and then assigning addresses to device. Okay, if it's a host user, the first is .1, the last is .229, and servers .230 to .239, .40 for printers, and .249 for blast. And for intermediate devices, .250 to .253, and the gateway is .254. Depends on the devices that you will use. Next is subnetting the IPv6. 16-bit, no, equivalent to the host portion. The interface ID is subnet is ordered to subnet with this site. Global routing prefix is from the ISPs prefix to ISPs. Let's see. Address block is ACAD 000. Okay. Then increment subnet ID to create 65 subnets. 65,536 subnets. So it will increment by 1, 2, 3, 4, 5, 6, 7, 8, 9 ABC. Subnets 13 to have 65,532 until FFFF is broadcast. I think it's the broadcast. IPv6 subnet allocation. Address block 5 subnets allocated from 65,000 available. So up to 0 up to 00005 64 available subnet. Then pwede sila maghati-hati. Then 001, 002, 004, 003, and 005 for all of the networks. Then I think it's done. Thank you for watching this video. I hope you learned something from me, and I hope you understand fully my video. I hope you good day, and thanks for watching.